welcome to the channel of Medical Device. Our topic today is MRI. Hi, my name is Mahrat. Why are you waiting now? Let's go. Introduction MRI. Magnetic Resonance Imaging MRI. MRI makes use of the property of nuclear magnetic resonance NMR to image nuclei of atoms inside the body. Next, MRI provides good contrast between the different soft tissues of the body, which make it especially useful in imaging the brain, muscles, the heart, and cancers, compared with the other medical imaging techniques such as computed tomography, CT, or X-ray. That's not all of it. It is a medical imaging modality which uses non-ionizing radiation rather than ionizing radiation to produce image of body structure inside the body. It uses magnetic field, pulse radio wave, radio frequency, energy, and computer system. In 1997, the first MRI was exam performed on human being. History about MRI. Victor Matfield developed a mathematical technique where it can scan a second radar producing clearer imaging. In 1997 and 1977, the first MRI exam was performed on human being. Paul Silverberg and Victor Matfield awarded in medicine their discovery of MRI. This is a comparison new device and old device MRI. New MRI and old MRI have a lot of improvement. Thank you.
My name is Kojo Hee. As your doctor machine, I have some information about component orders for you in MRI. The main components in MRI are magnet, gradient coil, SIM coil, RF coil, and computer. The functions of MRI components are a large magnet which generates a uniform magnetic field, smaller electromagnetic coils to generate magnetic field gradients for imaging, a radio transmitter and receiver and its associated transmitting and receiving antenna or coils. A computer is necessary to coordinate signal generation, acquisition, and image formation and display. Here shows the general design of MRI. Next, there are three layer information of MRI. Magnet, static magnetic field coil. It works under a principle of electromagnetism. Whenever an electric current passes through a conductor, a magnetic field is created in the region around the conductor. Gradient coil. There are three gradient coils within the main magnet. XYZ gradient coil, which produce three different magnetic fields, each are less strong than main magnet. RF coil. RF coil act as transmitter and receiver. They are used as the Z gradient coil in MRI scanner that transmit the RF signal and receive the return signal.
Principle of MRI. What can be diagnosed by an MRI scan? Most alignments of the brain includes tumors, spot injuries, muscular sense problems, most spinal conditions or injuries, vascular abnormalities, female pelvic problems, prostate problems, some gastrointestinal tract condition, certain ear, nose and throat ENT conditions, soft tissue and bone pathology or conditions. Principle. MRI makes use of the magnetic properties of certain atomic nuclei. Hydrogen nucleus, which is single proton, represent in water molecules and therefore in all body tissues. Lastly, the hydrogen nuclei partially aligned by a strong magnetic field in the scanner. The nuclei can be rotated using a radio width. They subsequently oscillate in the magnetic field while returning to the equilibrium. Simultaneously, they emit a radio wave. This is detected antennas, which is coils. Very detailed images can be made of soft tissues. MRI forms image with a reference to the hydrogen atom present within the human body. The principle of formations MRI image can be described as follows. Firstly, net magnetization, precision, then resonance, transverse magnetization, longitudinal magnetization, and lastly image formations. Measuring the MRI signal, the moving proton induces a signal in the RF antenna. The signal is picked up by a coil and sent to the computer system. Advantages of MRI: no ionizing radiation, variable thickness in any plane. Next, the better contrast resolutions. Lastly, many details without IV contrast. Disadvantages of MRI: it is very expensive. It is dangerous for patients with metallic devices placed within the body. It is difficult to perform on claustrophobic patients. Movement during scanning may cause blurry images. RF transmitters can cause severe burns if mishandled.
Assalamu alaikum and hi to everyone. My name is Muhammad Jawad and I will explain for development of MR imaging system radio frequency system. The radio frequency system comprises a powerful RF generator. The normal frequency at 1.5 is 63.8 MHz, which is in the range of FM transmitters, and a highly sensitive receiver. The stability of these two components is crucial, as both of the frequency and the phase of signal are needed for spectral encoding. Any disturbance, example by the phase rotation introduced by the receiver, would result in a blurred image. Moreover, to adequately detect the weak MR signal, effective RF shielding of the scanner room is necessary to prevent interference from external source. In figure above, a typical MR system employs RF amplifiers to produce high illuminating fields. When all of the power generated by their RF power transistors reach the load, RF power amplifiers must effectively have optimal relativity and have the longest operating lifetimes. The RF transmitter serves to deliver pulses that correspond to the resonant frequency of hydrogen atoms. Shapes of MRI machine. There is closed MRI and open MRI and upright MRI. Manufacturers of MRI. There is Hitachi and Philips and Siemens and another few companies. MR image quality. The quality of a medical image is determined by the imaging method, the characters of equipment, and the imaging variables selected by the operator. The figure below is an overview of the medical imaging process. The five major components are the patient, the imaging system, the system operator, and the image itself, and the observer. And the quality of medical image is determined by the image method, the characters of the equipment, and the imaging variables selected by the operator. Image quality is not single factor for the composite of the at least 5 factors: construct, lure, noise, artifacts, and distron. The relationship between image quality factors and image system variables. Conclusion: magnetic resonance image is one of the most efficient and inventions in the history. MRI made many things that were not possible earlier to be possible. Some of these things are the way that MRI examines the body. MRI does not relate any unhealthy waves to the body that can be mutate the human gene. Now I will leave you to see simulation video about how MRI works. Thank you so much.
Magnetic resonance imaging, or MRI machines, are powerful diagnostic tools that use strong superconducting magnets and radio waves to generate images of the body's soft tissues. Here we'll see exactly how the magnet's field interacts with the body to make those images. The human body is made up mostly of water molecules, or H2O. So it contains lots of hydrogen atoms. These atoms react in a very useful way to an MRI's main magnetic field and the radio waves it emits. In the nucleus of every hydrogen atom is a positively charged proton that spins around an axis, like the planet Earth, spinning with a north and a south pole. Normally, these hydrogen protons spin about willy-nilly on randomly oriented axes. Put them inside an MRI machine, however, and things change. Suddenly, the axes of the hydrogen protons realign with the powerful magnetic field and spin, just like a top, at a specific frequency, its resonance frequency, that is a function of the strength of the magnetic field, represented here by blue lines. Half the protons face in the direction of the field and the other half in the opposite direction. Well, not exactly half. There are a few more hydrogen protons arranged in opposition to the magnetic field than there are arranged in alignment with the field. Those protons, lacking a match among the oppositely aligned protons, are the protons targeted by the MRI scanner. Inside the MRI, an RF coil is placed near the part of the body being scanned. This is a radio antenna that transmits and receives radio frequency, or RF waves. The MRI technologist uses it to send RF pulses at the resonant frequency of the spinning protons. When the RF coil is turned on, the unmatched protons absorb the energy of the RF waves, which causes them to flip on their axes. They're still in line with the magnetic field, but now in the opposite direction. When the RF pulse stops, the protons release that absorbed energy, return to their previous alignments, and, in so doing, emit a signal back to the coil. Let's watch this one more time. The protons absorb the energy from the RF waves, then flip on their axes and emit the energy back to the coil. That signal gets turned into an electric current, which the scanner digitizes. The scanner processes the signal using advanced algorithms in order to produce the image. Tissue with less water in it will have fewer hydrogen protons to emit signals back to the RF coils. Those areas appear darker on MRI scans. The varying signal strengths get translated into various shades of gray, which radiologists recognize as different types of tissue on the scan. MRIs can be used to scan the brain, joints, and other parts of the body in order to highlight abnormalities such as herniated vertebral discs, cancer, stroke, broken ligaments, and aneurysms. The radiologist uses multiple RF pulses at different powers and in different sequences to manipulate the signal from those parts of the body.